Hey, we're live. Hi, Verge.
Hi, Mark. Welcome, everybody, to our AP Live. Ooh, there goes that transition again.
Yeah, I like that
Love
one a
that.
lot. So, I am Mark Corelli from Ryan High School in Denton, Texas.
And I'm Verge Cornelius from Lafayette High School in Oxford, Mississippi. And it's raining in both Oxford and Denton right now. Am I
Yeah,
correct about that, Mark?
yeah, in fact, they pushed the really severe thunderstorms back. Uh, so we should be off air. So,
Yeah, when I moved to the South, I realized that everything's late in the South, including the weather.
yeah. So if this gets shaky around 12:30 or my lighting appears to change because the outside lighting has changed, you'll find out.
Yeah,
Um,
I'm good. I can do
Right.
it.
So hey, we're here to do some AB calculus AB. I rearranged this slide a little. I'm taking advantage of our landscape and limited time. So today is not on there. So that's our upcoming lessons. And I wanted to add on here that they just last night we had our first look at a schedule for the week of May 4th to May 8th for an exam prep and send off week. So we will be they're extending our engagement, I guess is the theater way of saying it.
We just the show will go on.
And then the week after that, May 8th, four short days later on May 12th at 2 Eastern, most of you will be taking the AP Calculus AB exam. Some of you will be taking the BC. And, for whatever reason, some of you may then be taking it on June 1st. But
And that week beforehand, there's going to be some sort of AP prep with the different format of the exam. So just stay tuned for more information on
yeah,
that.
that's why I didn't fill in the calendar. I just
We don't
prep
know.
week.
Right. Yeah.
Um, and then we whipped through that last picture after one whole day with no mistakes. So we're digging the
Mm-hmm.
barrel now. So scraping the bottom of the barrel for pictures. This was actually taken at medieval times in Dallas on a Thanksgiving weekend, I believe.
Medieval times.
So that's why
And
we're wearing our crowns.
yeah, and that's an old picture of me for sure because I don't have those glasses anymore.
Yes, and I'm middle of that is a poor December beard for me actually. Either
That's no shave November, I bet.
nah, but yeah, but it was early on. I must have started late that year because that or it just comes in fuller now that I'm older. Um, So there's our introductions and warm up, or sorry, introduction banter and corrections. We didn't have any yesterday. Do you want to? I know people are working the circuits. I did not put the key up for Monday yet. I will put that up after we're done today. For those works, everything else is up to date in the Dropbox. So we'll get going on that. Going to do our warm up, differential equations. Did we want to talk about the Dropbox?
I think that's an important thing to do.
Hey, look, you can bring them back.
Wow.
Yeah, there was the updates on the exam. Yeah, this link actually takes you to directly to this, but we wanted to show you how to get to the Dropbox and maneuver it because we've been getting questions when people can't find things. So,
And a lot of times we talk
and
about
there
at
we
the
are
end.
live. Oh,
Wow.
it's videoception.
Uh-huh.
Um, and
We
so I
talk
wanted to
about it at the end, and then like we know people are just not with us at the
yeah.
end anymore.
So down here at the bottom, there was a show more or show less. I believe it's a little arrow on the mobile version, and you tap that bit.ly. And we also reorganized it. So if you haven't been in the Dropbox in a while, they're now labeled by episodes.
Oh
And
wow, you did do a lot since this
yeah.
morning.
And so we just wanted to talk about the fact that, today is episode 21 and there's today's stuff is differential equations, unit 7, and there's only one item in there.
Aw, that's
But
unfortunate.
but that's because if you look back at episodes 1 through 8, they were all 7.1, 7.2, and so on. And so there are a lot of Unit 7 reviews out there. You can look at the wrap up. You can pick something to focus on. But
There's tons of probably at least 16 resources within those 8 folders. So
yeah,
if you haven't been with us since the beginning, you definitely need to visit those folders for good practice.
yeah. But eight out of the 20 previous lessons were, about that. And that's nearly a third from the upper direction. So.
Mm-hmm. Also, talk about the home versus the files, Mark.
Oh,
On the
yeah.
side
If you
there.
the link takes you to this level, which is really nice. But if you accidentally click home on this folder, it's a mess. It's all and you guys may not even have access to home. That may be me because of what's shared. But if you ever click files, it organizes everything by date again and everything looks nice. So And then down here at the bottom is that our course schedule is down here, and then the AP course schedule here is when your exams are. That's a College Board link.
Thank you,
All
Mark.
right.
That's awesome.
Back to
Now
the
we're ready for
slideshow.
our warm up.
Where's
So
the
as he's
slideshow? There it is. All right.
So we're going to have a warm up, and then that notes template that is in the shared folder is what we're going to go ahead and work through as a Unit 7 review. So here's our warm up.
Yep, that's us. And it says, which of the following could be a solution to the differential equation dy dx equals secant squared x plus 2x?
All
And we'll give
right.
you some time to read that, to
Maybe
pause
pause
it.
it, think about it.
I guess I could read the choices for those of you that are on mobile devices. I don't know. A is 2 secant x, well, y equals 2 secant x times the product of secant x and tangent x plus 2. And then B is y equals 1/3 secant cubed x plus x squared plus 2. C is y equals tangent x plus c. And D is y is tangent x plus x squared plus 2. I said plus c on C, didn't I? Plus 2. All right. So
It's okay.
a constant 2.
So get your choice. And well, Mark, are you going to go to your overhead at this point, your document camera?
Sure, I can.
Okay. So I'll tell you everybody a joke. Remember, I had a plea for jokes, and I've gotten a ton of jokes. Just a couple of shout outs to Vienna, Virginia, and Menchville, South Carolina, who sent me jokes. I don't know if this one came from there, but this one's really for Mark. And he'll love this one. And the question is, Mark, are monsters good at math?
Oh, geez. Are monsters good at math?
Well, not really, unless you count Dracula. The Count. Huh? Oh.
Count von Count? Is that
the Count von Count?
All right. And I assume you're still seeing the PowerPoint slide. My camera decided today was the day that it felt insecure, and it was asking me to agree with the terms of agreement again.
I hear beep, 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 beep.
Yeah, that's it, focusing in. All right. And now you should see a blurry version of the warm-up there. Yeah.
Okay.
Yes, it's not quite as insecure as Apple that it constantly asks me to re-agree, but it's close. All right. So we could do this numerous ways, right? We could do separation of variables, but honestly, it's just
you've got only the independent variable showing there, so you don't really need to do.
Right. You can just integrate both sides with respect to dx, right?
Yeah.
And then that'll just be y, because those go away. And then secant squared is the derivative of what?
Tangent x.
Yeah. And that's what this problem is really asking, right? It's just saying, especially when it's all in terms of the independent, it's just saying, what is this the derivative of? And secant squared is the derivative of tangent. 2x is the derivative of x squared. And since they're added, I can do those separately. And then this is a general form. So plus c. And of course, some constant not named x or y, right? You can lowercase c, capital C, which that's my attempt at a capital C.
Right.
I did minus c on one of my keys yesterday, and Verge told me to stop.
I think that was this morning.
Was it? It seems like it was so much longer ago.
I know.
All right. So it looks like our answer is D, because C was 2 that time. So because it did say could be a solution, not has to be the solution, right?
Yeah, because the derivative of 2 would be how much?
That 2 is not changing when x changes, so 0.
Right. So that's why we don't see it in the dy dx equation, in that differential equation.
Awesome.
So this entire unit 7, is differential equations. Like, that's what it's called. And there's a differential equation that we've been looking at since unit 2, really. And so as we move through some of these review problems that we picked, and I think, Mark, you're going to do the front side of the notes page,
yes,
right?
That was the plan, was I was going to do the front. So I'll go
as
back
we
to my
move
camera.
through these notes that we picked, you know, there's a lot of stuff that we've kind of already done in our lessons, but some folks haven't been joining us the whole time. And, you know, third time's a charm. You might have done it in school. You did it with us in our lessons. And now we're going to do it again, like getting ready for the exam. You're going to feel like you own this stuff, you know, so it's going to be great. Okay.
All right. So hopefully you're seeing what I'm seeing, which is not. No.
Kind of cut off on the side. Maybe you need to zoom out a little bit.
Let me reshare this. Oh, it went away. Oh, no. All right, we're going to try this again. There. Okay. It was when I went full screen, it didn't like it. Okay, so are you seeing the camera now?
Oh, I'm seeing everything. It's just that it's cut off a little
Okay.
bit on the right-hand side.
Yeah, I wasn't
Oh,
even,
yeah,
it
that's
was
better.
telling me it couldn't even share the camera a second ago, so that was
Okay.
fun. All right. All right. So hey, and we do have a note at the top of the notes, or Verge put this here for you. Videos from March 25th to April 3rd cover the unit. So again, access the Dropbox for that. The Dropbox. That's like that'd be like some new wave like hip hop
Mic drop.
classical rock crossover. That'd be awesome. Okay. So we've got the rate of change of the height, example 1, the rate of change of the height of a tree H in meters with respect to the age of the tree T in years is inversely proportional to the product of the time and the cube root of the height. Write this situation as a differential equation. So there's a lot there that you might start doing, and we see that at the reading, right? Like, I'm going to solve for H. But again, reading the actual question, they just want us to write a differential equation, and then we're done, which explains why you gave me so little space.
Mm-hmm. Hint,
So
hint.
break it up into phrases here. The rate of change of the height of the tree, dH, and I'm going to change colors every time just to drive you nuts. With respect to the age of the tree, time. We had a discussion about this right before going on air.
Yeah, I'll get you later.
Yeah, I know. I could also do different underlines if I'm not allowed to use colors, right? Is inversely proportional. So that immediately is K or A or some constant over, right? Inversely, it's the multiplicative inverse. And I'm actually running out of colors. The product of time and the cube root of H. So T times the cube root of H.
Nice.
And of course, I could do that in either order. That could be H to the 1/3. There's a lot of correct ways to write that equation, but that is what they wanted. So if I box it, yay. All right. So obviously there's more we can do, right? So let's look. I'm going to bump up against the picture of me in the corner here. Example 2, for what value of K, if any, for what value of K, if any, will y equals e to the 2x plus ke to the negative 5x be the solution to the differential equation 4y minus y double prime equals 30e to the negative 5x. So this is actually similar to our warm-up. We're doing a verification. They want me to verify this equation over here, which is the 4y minus y prime. Is that cut off, or can you?
No, it's perfect.
Okay.
I can see it.
The 4y minus y double prime, and we have y. So I'm just going to go find some derivatives. We're going to go find y prime, which will be 2e to the 2x. It's
Chain
e to the
rule.
2x is the exponential, and then we chain out a 2, plus k's along for the ride. It's a constant, and there's that prophetic space there. E to the negative 5x, the exponential gets repeated, but I chain out the derivative of negative 5x and get a negative 5 out front. And then my second derivative, and I'm going to go to the right here because I know I have a limited space. My second derivative, e to the 2x's derivative again will be e to the 2x times another 2. So 4e to the 2x. Negative 5k is along for the ride. Going to get multiplied by a chain of negative 5. So 25ke to the negative 5x. And now we're going to come in and try and verify our equation over here on the left, this guy 4y. So we're doing 4 times y minus y double prime equals 30e to the negative 5x. And I'm just going to insert my second derivative. And my first derivative. Or no, not my first derivative, just y, right?
Yeah, that's a good That's good to like kind of, pay attention to that, because sometimes differential equations have a y prime and a double y prime and a y.
Right.
You got to read what you got there,
and plugging it in the wrong spot blows the whole thing up, right?
yeah, right. Don't
So,
misinterpret the question.
all right, here I have a 4e to the 2x, and here I'm going to have a negative 4e to the 2x. So those are going to kind of go away, right?
Mm-hmm.
But then I am going to get this 4ke to the negative 5x minus. I usually don't tunnel under that parentheses both times. I usually go under one and over the other, but
Mm-hmm.
I have space issues.
Yep.
I always wonder if that's like, do you tunnel under the wall or jump over? What's your philosophy?
I generally go over the top, but I've been teaching distribution with the area model in Algebra 1. So sometimes folks even write like a little rectangle out to the side to do their multiplication.
Oh, yeah.
So,
All right. So here's what I got left over, right? I've got 4ke to the negative 5x minus the 25k to the negative 5x equals this 30e to the negative 5x. And we have like terms.
Yep.
So really all I'm having to set equivalent is my coefficients.
Yep.
So 4k minus 25k is negative 21k equals 30. K is 30 over negative 21. Of course, perfectly valid place to end on an AP test. Go ahead and box it. But,
in real life,
negative 10/7 or negative 1.3.
Well,
yes.
negative 1.3, negative 1 and 3.
Oh gosh, 3/7. So what's that? 0.43,
Something like
0.42,
that.
something like that. All right. Yeah. Sorry about that. Thank you for catching that.
No problem. That's why I'm here.
Okay. So take a screenshot. All right. Actually, don't take a screenshot. Go do it yourself
or
later,
rewind.
and then come back and watch the video again and check yourself. All right. Oh, okay. Or come back Wednesday and get the key off the Dropbox, or today's Wednesday, Friday. All right. Number 3. Consider the differential equation dy dx is equal to the opposite of y squared divided by x, and obviously x cannot be 0. Let y equal f of x be the particular solution to the differential equation with the initial condition f of negative 4 is equal to negative 2. And A says to sketch the solution curve. Oh, whoops. Sketch. It should be. I think it was really supposed to say tangent to the point.
Maybe so.
But
through the point is good.
It doesn't. Too. Yeah, it should just be through the point. Editing error.
Okay.
So sketch the solution curve through the point negative 4, negative 2, and sorry, scoot that down a little. And there's more here, and I suggest this on the exam day. I read one at a time. I know some people like to read and say, "Oh, which ones can I do?" But I'm just like, I'll forget about A by the time I get to C.
And you can do it, by the way. Like if you couldn't do A, then it would be good.
Yeah, if I could do it, I'd move on. Right, exactly. No, you're right. Because sometimes they are independent. And so I'm starting at this point. There's my point, negative 4, negative 2. It was labeled. It's not real dark on my copy, but and now I'm just kind of using these as guidelines as my threads. I do see a horizontal tangent here, which I'm never actually going to get to. That's actually going to kind of be asymptotic. But I'm going to approach it, and it looks like we're going to hit right at the origin, and I'm going to put a hole because x cannot equal 0, but that's going to be the end of my graph on that end, and then come back through there. So that's going to be my solution curve. Because this thing may pop above, it may go down, it may continue. We just don't know, because that's the end of the domain for this point in this equation.
And we spent an entire class period lesson on that, like in our live sessions. So if you want to go back and revisit that, even some teachers, I even learned a lot from Mark on that, because I hadn't really ever graphed anything where there was a hole before. Let's just put it that way. So on a solution curve, on a slope, right? On a solution curve of a slope field, right? So
we have a point. We need a slope to write the equation of the tangent line to the solution curve at the point negative 4, negative 2. So we're at the same lane. Now we're trying to find what the equation of that tangent line through there would be. So to find the slope, I'm going to evaluate dy dx, at -4, -2. I probably wouldn't write that if I was doing it myself. I would just write m equals and do it, but we'll be nice and formal here while we have some time and someone looking over my shoulder to verify I'm doing it right. -2 squared is 4. Opposite of 4 over -4 is 1. So our slope is 1. And I will write both versions because I don't know. Verge would write it like this.
And I would
And
stop.
I write it in the Taylor form. I'm not moving that 2 over and simplifying. I just always put my initial y as plus m x minus x0. So
But make sure your initial y is negative.
right, either
because
one.
it was a no,
You're right.
yeah.
I'd subtract it over.
Uh-huh.
That's a good reason why I don't do it that way, because I'm going to need that form anyway. So yeah. So again, we did this whole discussion in those videos if you haven't, but it's just whether you learned point slope like this, or if you learned it. Oh, I'm probably up under there. Learned it like that, or learned it like this.
Mm-hmm.
All right. So there's my tangent line. Now it says use the equation of the tangent line for this. So f of -4.1 is going to be approximately -2 plus 1 times -4.1 plus 4. And I'm done. That's a numeric answer. But in real life, that's going to be -1/10. So -2.1.
Yeah, and I actually had a student message me about which one would be better to use, and I told them, on the AP exam, because you're pressed for time, and we want to evaluate you on your calculus knowledge, not on your addition and subtraction knowledge. Leave it in a numeric form is totally fine, but in real life, you have to usually get to the simplest form.
Right, and also for reasonableness. If you want to check to see if it's
absolutely,
and if you want to check to
answer.
see if it's reasonable, and then you cross it out, and then this becomes your official answer, because crossing out is the same as erasing. So you can kind of use that as a powerful tool of I'm going to simplify to see what it looks like, and then I'm going to pretend it's not there.
Yeah, just because for that internal dialogue of I think it should be like in the third quadrant and blah blah
and
blah.
it should be probably a little bit above, like if I'm going left, right? So left, right. If I'm going left, correct, it should be a little lower, and you can kind of follow the slope field. All right. D, find the particular solution y equals f of x to the given differential equation with the initial condition f of -4 is -2. And I recopied this just because I knew I was going to have to scoot the page up. So, oh, Verge, what to do now? There's y's and x's over there.
Separate.
Integrate. That's from a song I knew. And you could put it as over y squared. I'm putting it as -2.
I wouldn't bring the negative to the other side, but that's just me. You're good.
Yeah.
When I say the negative coefficient.
She means this negative. Yeah, that -1 could stay over here. That could be -1 over x dx. And I could have written that obviously as 1 over x dx, but I wanted it to look like our cabin joke. So -2 plus 1?
-1.
-1. And then divide by -1. And that's why I brought
the
negative over. I know.
Thinking in advance.
It's sneaky when you're moving points of it in front. And then derivative over function, or just 1 over x's antiderivative, is the natural log of the absolute value of x. And then plus c. And that c takes care of both sides, because if I had a different c over here, that just changes this c. And now I want to look at -4, -2. What's going to happen? So I'm going to plug in my -4 for my x and my -2 for my y, and I'm just trying to find my c. And it looks like c is the natural log of 4 minus a half.
I feel like we had
I lost a negative. Nope.
No,
that's right.
You know what? For your equation, it's right, because my negative was on the other side.
Yeah, the c's are personal, but it's consistent with mine. So. All right. There's probably more than 7 of them too. All right. Plus log 4 minus a half. All right. So there's a start, but they wanted me to find y equals a function, and right now I have 1 over y equals. So I'm just going to reciprocate both sides. And this is what I do with my fingers. I know Verge does this too. Just flip both sides. You can also put it over one, cross multiply, whatever makes you happy. And that's my final equation. And you could simplify this. Obviously, the complex fraction is going to make people nervous about the back of the book. The key on publishing Friday, we typed it up nice with a 2 on top and all that good stuff.
Hey, Mark, I'm feeling pretty
Yes.
proud of myself because I did find your mistake just now.
Ah, where is it?
Okay, so natural log of the absolute value of -4 is natural log of 4, and when you bring it to the other side, it's negative.
Thank you. Boom, 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 boom.
No,
Yes.
no, not there. Okay.
Yes,
So,
there. Oh, there. Gotcha. Trying to fix it too fast.
Yep.
Yeah, because now this looks like that solution I got, because we did have the negative in a different spot later, and then I did a bizarre exponent trick to fix it. Because I had x over 4 at the end.
Okay, all you haters out there, we fixed it in real time. This is amazing. Kidding. Okay.
Just beat the text message I got.
Okay.
And then, of course, for those that really want to see it, but
is that right? You got to have a 2 out front of the natural log there.
Yeah, there we go.
Yeah. Okay.
Yeah, but I don't want to do that because of that, right?
Yeah. So. Okay. So I think I'm taking the next ones, right?
All right.
Okay,
good.
you got to watch me, Mark, to make sure I don't make any mistakes. Right? Yeah, like we don't have to actually
it is funny though.
Have to plan mistakes because they're going to happen, right?
And it's funny because you think it like, oh well, don't they do them ahead of time? It's like, yeah, but when I did it ahead of time, I didn't move the negative over, so it doesn't look the same.
And there's so many different ways to do a math problem correctly that know. Just the spirit moves you to do it different way the next time, right?
But math works. That's
math works if you don't make errors. That's
even if
sure.
I don't.
Okay, so this is our reminder to myself that it's Wednesday. Okay, good, we're good. All right, so example 5. It says the point 1, 2 is on the graph of the solution curve to the differential equation dy dx is equal to, why am I doing 5? Instead of 4, I'll do 5. I always go out of order in my own classroom anyway. The point 1, 2 is on the graph of the solution curve to the differential equation dy dx equals x plus 2 times 3 minus y. Find the y coordinate such that the point 2, y is also on the graph of the solution curve.
Is the AC on?
Okay. All right.
I unsuccessfully tried to mute myself on that. Sorry about that.
That's okay.
I was asking my wife.
In the South, when it's raining, you actually have to put the AC on because it gets so humid so fast.
It's just the humidity, yeah. And I'm wearing long sleeves, but that was just so I'd fit with my background.
So here, dy dx is equal to x plus 2 times 3 minus y. So to solve this differential equation, I have to separate. I have to get the y's, or that y expression, over with that differential, and then move my dx kind of to the other side. Think about it that way so that I'm set up to integrate. This is hauntingly familiar to what Mark just did, so it's a nice problem to follow with. With the 1 over x, the integral of dx over x, we got natural log of x, absolute value of x. Here, this denominator is a little bit more complex, but not much. What's the derivative of the denominator with respect to y, Mark?
Ooh, -1.
Right. So this one, I wouldn't really do a chain rule on it. I would just recognize the structure here. And then I would say that this is going to be negative the natural log of the absolute value of 3 minus y. On the other side right here, I have to anti-differentiate x half squared, anti-differentiate 2, and I get 2x, and then plus that c. Again, if this is the first time you're watching any Unit 7, we're going very quickly. I would encourage you to go back and watch all of what we taught really on why we're only putting the plus c on one side and stuff like that. All right, so my initial condition was that when x is 1, y is 2. I'm going to substitute that in before I do any algebra and find my c value. So negative the natural log of 3 minus 2 in absolute value, because the y is 2, is equal to a half times 1 squared plus 2 times 1 plus c. So here, let's see, I have a half plus 2 plus C. And over on this side, I have 3 minus 2, which is 1. And what's the natural log of 1?
0.
0.
E to the 0 is 1.
Okay, so my C value ends up being negative 5/2 or negative 2.5, something like that. All right, so now I have negative the natural log of the absolute value of 3 minus y is equal to 1/2 x squared plus 2x minus 2.5. And I'm going to go ahead and solve for y to get my particular solution, and then I'm going to answer the question and plug in x, and then I'll have the answer to the question. I wasn't prompted to find the particular solution here. However, I have done this problem several times, and if you don't find the particular solution first, you're kind of in the weeds as to what to pick for your answer choice. And I'm not going to go there with you right now. I'm just going to go ahead and do good calculus and well, I guess it's actually really algebra that I'm doing right now, and just get that particular solution. Okay, so I'm multiplying my entire equation by -1. Then I'm exponentiating, so I have the absolute value of 3 minus y is equal to e to the, all this stuff is up in the exponent, -1/2 x squared minus 2x plus 2.5. Remove the absolute value bars, and that gives you a plus or minus e to the, all that stuff, still the exponent binomial. Okay. And then I'm going to subtract 3 from both sides. So I have negative y is equal to -3 plus or minus e to the -1/2 x squared minus 2x and then plus 2.5. And then multiply everything that's negative again. So I have +3. When I multiply plus or minus by a negative, I have plus or minus. And then I have all this stuff still up in the exponent. Okay. Long story short, I really need to do this so that I know which branch to pick of this solution. Do I want 3 plus e to the stuff, or do I want 3 minus e to the stuff? And why?
Yeah.
I want 3 minus e to the stuff because when I substitute in 1 for x, okay, this exponent is going to become 0. E to the 0 is 1. And then 3 minus 1 gets me 2 instead of the other way around. If this was 1, 4, then I would want to do the 3 plus. So I have 3 minus e to the all this stuff. Okay.
Nice.
And then that's my particular solution. Now I have to figure out when x is equal to 2, so 3 minus e to the -1/2 times 2 squared minus 2 times 2 plus 2.5. That would be my value of y when x equals 2.
Yep.
And I think if you just are that kind of a person who needs to have that exponent, just makes you feel like I'm going to throw up. It's so unorganized. What would that exponent have been? I think it's -2.5 if I look back at my notes.
It's -4,
-3.5.
-3.5, yeah.
Okay. Okay. Again.
Or -7/2 if you're
Sure.
even
Yep.
more. 1
Yeah.
over the square root. No, anyway. 1 over e cubed times the square root of e.
Yeah.
By the way, I just want to interject because I know, obviously we have people coming to us from all, hopefully our kids are watching. I didn't. But
Hi, Faye again.
but a lot of teachers will wait to find the C. They'll get the y alone, then find C. And the reason why Virg and I both do it, or at least part of the reason I do it, I've always done it this way, but from an AP standpoint is, we talked about how you have to there's different C's, right? That my C was the opposite of yours because of the negative sign. But the C you find or are trying to find has to be consistent with your antiderivative in your equation when you plug in the point. And so if algebra mistakes happen, and we make algebra mistakes, I had one on the last problem. If an algebra mistake happens before you try to find that C, you actually can lose a point that you otherwise would have earned. And so if you
the
hop
way
in
the scoring rubrics are
the way
written
the
for
scoring
AP,
guidelines
yeah.
are, the way they're scored. So this, as soon as you take that antiderivative, go find that c, because it's not even finding the c, it's plugging in the point at a level where you would get the consistency, the consistent c that gets the point, right? And if you miss up a sign somewhere before plugging that point in, then you've put that point in peril, and we don't want to do that.
Because really, I'm going to go ahead and do this. That's all the calculus.
Right.
On the
and
page.
that would earn the
And
first
that's
2 or 3
worth
points. Yeah.
almost all the points.
3 or 4 actually. Yeah, right. Because the
Yeah,
separation.
the rest of it is the algebra, which is why you get so good at algebra and trig when you do calculus, because you're doing so much of that. So yeah, that's worth all the points, or most of the points.
Yeah.
Significant portion of the points. Yeah. Okay. So speaking of trig, question 4.
You're doing 4 or 6 next?
I'm doing 4. 6 has a natural log in it as well if you choose to do it that way. So I'm figuring like, you know, we could save that as something we do tomorrow or whatever if we run out of time. We've been holding them a little too long, and this is going to be a long one. So
okay.
Okay. Well, we'll see. All right. So example 4. Given that dg d theta is equal to theta sine theta squared all divided by g, and that g of, boy, this is ugly, the square root of pi over 3 equals -2, determine g of the square root of pi over 2. That question's like, wow.
That's
you know,
signs of a loaded problem is what I think.
Yeah. Okay. You know, like, you know, like you can do it. If people who are nervous about different variables, you can definitely rename all your variables if you want. Just make sure that you rename them consistently. You know, call the dy dx, you know, and then make this a y and make that an x or whatever it is you feel like you need to do. Okay. That's totally fine. I wouldn't do it for the first time on the AP exam. I would start practicing that technique now. But in any case, got to separate here. So dg, is that g going to be underneath the dg?
Only if you do it wrong.
Only if you do it wrong.
Going to multiply g to both sides. I think
multiply g to both sides. Okay, so we're going to separate here. Get that d theta over with its theta compatriots, and then we're ready to integrate. So the integral of g dg is just 1/2 g squared plus some constant of integration, but again, that gets lumped in at the end here. And then on this one right here, the integral of theta sine theta squared d theta, this to me is a chain rule, but it's almost one I can do in my head at this point, because if I kind of come over to the side here and think about, well, u would equal theta squared. So what's du d theta? Theta squared being my inside function. So what's du d theta? That would be 2 theta. So really, I'm really just off by a coefficient. And Mark did this the other day. Maybe it was yesterday. I don't know these days.
That may have been this morning.
Yeah. I mean, like me personally, when I'm doing this in my head, I think to myself, okay, so I'm going backwards. So really, I need a 1/2 to compensate.
Uh-oh. Okay. I lost you for a sec.
Okay, antiderivative of sine is going to be negative cosine. So we generally put the negative out in front of the coefficient. Otherwise, it looks like a subtraction, or we have too many parentheses. So here, this would be the antiderivative of theta sine theta squared, and then plus a constant. So let's see here. I would then go right away and substitute in my initial condition. So -2 is that g value, 1/2 times -2 squared equals -1/2 times cosine of root pi over 3 squared, and then plus c. Now I'm feeling a lot better about that square root of pi over 3, because now I just have cosine of pi over 3. And I just need to think about where that, what that might equal. -2 squared is 4. A half times 4 is 2. Let's see. So 2 equals -1/2 times whatever the cosine of pi over 3 is. Again, this is kind of like my thought bubble over here. Me personally, I did not memorize unit circle when I was in high school. I did not go through college doing unit circle or anything like that. But when I started teaching, I taught with somebody who taught that way, and I thought, wow, that's such a better way than memorizing a table, because it gives you a visual of what's happening and how the pattern is repeating. Anyway, so here's my pi over 3 in the first quadrant, and I know the cosine is the first coordinate, so I've got a half there. And then plus c. So -1/2 times 1/2 is -1/4. Add that to both sides, and I get 2.25 is equal to my c value. So far, so good, Mark?
Yeah, I actually have a theory that whichever method you see second is always going to be the method you prefer, because you already know the answer. If you'd learn the unit circle first and then you see a table, you're like, oh, the table organization makes way more sense.
Huh. Maybe. I'll have to think about that.
It's a thought. It's a thought for another day. But yeah, it seems like, because kids are always like, you're so good at teaching trig, and it's like, yeah, because you learned it last year, and I'm just repeating it.
Yeah. Yeah, it's true. Yeah, I can totally see that. I don't know. And then when you generate the sine graph off of the unit circle, and you see that periodic function, that sinusoid, and understand that it's kind of going around like that, I don't know. To me, it's more animated in my mind now than it ever was before. Okay. All right, so I have a half g squared equals -1/2 cosine of theta squared plus 2.25. So I'm coming back up to this line right here and just substituting in my c value. Now I'm going to solve for g. So I'm going to multiply both sides by 2. So I get negative cosine of theta squared, and then plus, this is messed up this morning, it should be plus 4.5, not what I wrote down. And now to finally finish it off, I got to take the square root of both sides. When you do that, you have the positive and the negative. This time, which branch do I want to pick, though?
Well, the point they gave us equals -2, and the only way I'm going to get -2 out of that root is if there's a negative in front of the principal root. So we're going to choose the negative.
That's right. So squared plus 4.5. Okay, so that's my particular solution. And now I can substitute in the square root of pi over 2 to that theta, and I can figure out g of square root of pi over 2. So g of square root of pi over 2 is equal to negative the square root of negative cosine of root pi over 2 squared, and then plus 4.5.
That's hilarious, because when I did this earlier this morning, I had to extend my radicand afterwards, my radical afterwards also.
Yeah. So this is actually even nicer than I suspected. Square root of pi over 2 squared, of course, is pi over 2, and the cosine of pi over 2 is going to be nada. Yes, that's when you say, what's up? And a math person says cosine of pi 2. In other words, nothing. All right, so my final answer is negative square root of 4.5 and or any incarnation of that that's equivalent.
And you want to scoot it up to see the box.
Oh, sorry. Yeah. So this can be written lots of different ways, including, okay, should I go for this one?
Well, I was going to, yeah, go for that. But while you're doing that, I was going to say you can actually stop at the line where she plugged in the pi over 2. Because that cosine,
on the AP exam,
that cosine is considered numeric, because you could plug it into a non-graphing calculator and get a numeric value.
Yeah. But this is how a mathematician would probably do it, and
unless they're over 60, then they'll do 3 root 2 over 2.
Right, because they have to use slide rules.
Because they remember using slide rules and tables. Yeah. Ha ha. Me and my fancy electronic book, we know how to get that decimal.
Yeah, right. Okay, good. So we're at the 45-minute mark, and I
Yeah, perfect.
45-minute mark. So I think I'm going to save example 6 for our warm-up tomorrow, because tomorrow's lesson is a wrap-up of units 5 and 6 and 7. So we can absolutely start with a warm-up from unit 7. So go ahead and work on that this afternoon or tonight, and see if you have it right when we tune in tomorrow.
And it's thanks for watching, but it was funny. You know, they said the rain was going to come near the end, and the sun just, you know, hole in the clouds just went by outside the window. So.
But not on your virtual screen.
Nope, not in here. Poor guy that keeps walking across this in the background. But we hope we'll see you tomorrow. There's the link to the Dropbox that we showed you at the start of the video again. If you came in late, at the start of the video, we showed you how to navigate the Dropbox.
And there's nothing in the Dropbox except for unit these notes that we mostly did today.
That's
You've
right.
got to scour the old episodes to find
the first 8 episodes. And yeah, we're 21 in. Wow. And again, we've got renewed for a second mini season, May 4th to May 8th. We'll do some exam prep and for this exam. So we'll see you tomorrow.
We love you guys. Do your calculus. Bye.
My group, I'll see you in about 15 minutes in a Zoom meeting.